give you some idea of what the test is about, I'm going to go through all the presets that we have established for this coil. And I'll do that on the touch screen. Again, the touch screen is where all the unit presets are made and where all the testing is done. All the information to the operator is through the screen. Okay. The first variable we have up here is the pump startup delay. That's just a system preset that when you turn the system on, the pumps come on sequentially instead of all at once. Nitrogen backfill. This is in Tor. We put a slight positive charge in the unit after the test is complete to make sure that the when you disconnect your hose from your unit, you do not inadvertently pull the surrounding helium mixture into the hoses. We have a nitrogen backfill watchdog timer that ensures that the process is taking place correctly. We set up for our crossover valves, which are our vacuum valves in the unit, to give them time to open and close mechanically. Here is our helium to air ratio. As you can see, it's now set for 15%. And our differential is if it drops down to 0.5%, the helium is replenished. The helium ratio watchdog is set up for time of 300 seconds. That's to ensure that if it can't get to its prescribed amount within that amount of time, that means that you have a problem with your helium supply. Our nitrogen backfill buffer timer is set at 0.5 second. That's to, again, once the pressure is reached, that gives us a certain amount of delay to make sure that the mechanical valves have shifted. First, roughing vacuum. When you first start the test, we pull a vacuum down to 20 torr. At the end of that first rough evacuation is when we'll do a backfill with nitrogen. And then we'll start a second rough evacuation. Again, down to 20 torr. So we've gone through and evacuated the unit slightly. We've done a backfill with nitrogen to help pick up any water vapor that may be still in the unit. And then we start our second rough evacuation. And our rough evacuation is done with one of the 2 vacuum pumps associated with that side. First, high vacuum. The high vacuum is we need to get the unit down to 100 microns before we can introduce it to the helium mass spectrometer. High vacuum only means that instead of evacuating the unit with 1 vacuum pump, we're evacuating the unit with 2 vacuum pumps. And this is the pressure of 100 microns. And then once we get to 100 microns, we go into what we call our extended evacuation, which is once you've reached a low-level preset, we add a time value evacuation to ensure that you have hit the lower limit for a certain period of time. It's just to make sure it's a reliable number at 100 microns or less if it's working properly. Then we go into our vacuum pressure rise time. The vacuum pressure rise measures the decay, the vacuum pressure in the unit over a period of time when the unit is isolated from the vacuum pumps. It's very similar to an air conditioning requirement before filling. We make sure this test tells us if it stays below 1200 microns for 5 seconds, that the unit is tight, there's no large leak, and is holding enough pressure so that it can be exposed to the mass spectrometer. second watchdog is again to make sure that when we start our processes, they have to perform well within these time periods. Again, this is a fault preset. Final high evacuation pressure. At the end of the pressure rise test, we again evacuate the unit, the internal circuit of the unit, to this value just prior to shifting the valve to the mass spectrometer. So again, we go down to 100 microns, and this time we say our extended high evacuation time period is 15 seconds. Again, that's to make sure that you get to the low level, and then added time to ensure that the unit is within reason to be exposed to the mass spectrometer. And just to give you some idea, I'm going to shift this from 15 seconds to 10 seconds, just to give you some idea how easy it is to change. Now our final extended evacuation time period is 10 seconds. All right, now we're into our presets for our helium mass spectrometer. We're saying we want to witness the internal circuit of the coil for 10 seconds. This is our mass spectrometer test time. The helium mass spectrometer has several outputs that are provided. We use both of them for our purposes here today. We have set this up for an analog. So when I show you on the screen, you'll be able to read the mass spectrometer right on the screen. And it'll be in an analog format similar to a gauge, a digital readout. Now, this is our failure point for our helium mass spectrometer for any unit. We're saying that if the leak rate witnessed by the mass spectrometer is greater than 8 times 10 to the minus 7 power, we consider that a leak. And we've done that, determined that through our small leaks that we use, which are less, are a tenth of an ounce per year refrigerant of R22. The leak rate, that would be 2 times 10 to the minus 5. But because we have a 15% ratio of helium instead of pure helium, we back engineer that value out to times 10 to the minus 7, which is 2 decades higher than the standard tenth of an ounce per year leak rate, which is 2 times 10 to the minus 5. Okay, so we'll return to the home screen. All right, what we will do is turn on side A, which begins 2 vacuum pumps for the rough evac. The second pump is for the high evac.